consistency with
Yes.
Cassandra.
Yeah.
And as a developer, I have control over consistency level, right?
Even
From my code.
Even with Cassandra, you can set it up in this way. But typical usage is what I'm just talking about. Typical usage. Even with Mongo, you can set up some interesting things. But typically, Cassandra, I've seen it used in a heavy write, less consistent than it. But you're right, you can set it. And I'm seeing more and more usage of Cassandra, and I'm typically seeing it in the data warehouses of our enterprises. And so we talked a lot about the advantages. There are several significant disadvantages as well. And the most prominent one is that it's not ACID compliant. Like if you are used to a world where you have transactions and everything is isolated, consistent, you'll be in for a root shock, right? Because there's so much flexibility. It's completely up to how you're using the database and what the limitations of the database are. So you need to be very aware of what exactly is going on. Like for example, if you're writing a banking applications, you should do it in an RDBMS because that's what they were designed for, right? But if you're storing like tweets and analyzing them, then I think NoSQL databases are a better fit. And there's a lot of, like we talked about, right? The flexibility gives you a lot of room for error. Like you can make a lot of typos. Like for example, you can be missing fields, and your queries would never know. So right. So you got to be very careful. If you want consistency, you have to enforce it up front in your application.
And by the application, I guess you're saying the user interface then,
or the whatever server code is there.
Okay.
So like for example, if I submit some data which doesn't have the last name, you reject it. You say, hey, I need the last name.
So in a traditional relational database, for like a web-based application, you've got some of the code is on the browser side, and then you've got the business rules in the middle, and then you've got the database.
Yeah.
And used to be that you could put a lot of the data rules, you wanted them in that RDBMS, because that would handle it. But you're saying you're either putting it in the browser or you're putting it in the business rules code.
Yeah, like you said, there are 3 places.
Okay.
So typically what you will see is the validation happens in all 3, right? Like for example, there is some validation in the UI, but there'll also be validation in the server because there are probably APIs people can call.
Yep.
And then the DB admin also has some built-in, like in variables. Like he'll go put in a constraint saying it's a required field. You can't miss that.
Yep.
So there are 3 levels of safety.
Yep.
Now, what's happening with the NoSQL systems is the database level of safety is extremely relaxed. So you, as a DB admin, you can't go in and say this field is required.
You can't say that at all.
You can't say that. There are some ways you can achieve that, like I said, using indexes, and you can
unique indexes. You
can do all those things, but in general, the schema is, there's no schema, right? So it's very loose. It's very open and flexible. So it's completely up to the app to do all the validation.
Okay.
So data, for example, with stock procedure, whatever it is, you can filter the data.
Yeah.
So in this case, more likely a large amount of data has to be retrieved from the database and do a kind of a filter and join, whatever, at the application level.
Yeah.
So the network traffic.
If you're using a lot of stored procedures, you will generate a lot of traffic because there's no concept of stored procedures. Because everything has to be retrieved out and parsed.
Yes.
I mean, a lot of databases have built-in scripting languages. Okay. Like for example, Mongo has built-in JavaScript, so you can run JavaScript procedures on the server.
Okay.
But they're very slow, right? They're typically fairly slow.
Okay.
And you're probably better off just again, it depends on the size of the data you're retrieving.
Yes.
If you're working on gigabytes of data, then you're probably better off just running JavaScript on the server. But otherwise you just download it and you run the code.
Okay.
What are the performance bottlenecks we can hit potentially? I mean,
so all the performance problems remain the same, right?
Really?
CPU, memory, and disk. Right? Wherever you go, you'll end up.
I mean, if it's a traditional database, we always look for alternate indexes and that sort of thing.
Yeah.
So here is other control over
yeah. So even here it's the same thing. Make sure your queries are hitting indexes. You got to look at the query plan.
It's the same kind of.
Same.
It's
they also have an execution plan.
Mongo has a query plan.
Okay.
Cassandra is a little different, and they have their own different ways of doing things.
Okay.
But it's all the same. It's different, but problems are very similar. You have to make sure your query is scoped down, it's not doing a table scan.
Okay.
Make sure you have the right indexes.
Okay.
And make sure that your queries are not churning the working set. Right? So, for example, if you have one query that brings in rows 1 to 1,000, the other query comes in, brings in rows 1,000 to 2,000, you basically just keep churning your working set. Right?
Yes.
So the same problems, try to keep pages in memory, locality of reference, the same, all those skills carry over.
So NoSQL still need DBA or kind of work on that?
I mean, it kind of does, but I typically don't find any.
Yes.
Because the sort of people using NoSQL are mostly all DevOps people.
Yes.
Right? Because most of the adoption today, and I've got a slide about that as well, most of the adoption today is in the web properties. And all the web properties, it's all startups. They don't have the concept of a database guy, right? It's all developers. Right?
Yes.
And one developer gets chosen to be the DB guy. That's it. Right?
Oh.
And as they scale, they'll have more needs. They'll have more needs, and the simple reason is that expertise does not exist today. Like if you went out and tried to hire a Mongo DBA, you wouldn't find anything because that concept doesn't exist. So essentially, you make one of your developers into your Mongo.
That's very interesting.
Yeah, and that's why companies
That's
make
why.
we're like an outsourced MongoDB.
Yes.
Yes.
Because that's just the reality. I mean, you're a startup, you can't, you gotta get the right code, you gotta build a product and sell it.
Yeah.
So you got two guys in the company, right? One who's technical, who can build something, and the other guy who can do all the rest of the stuff. The concept of DBA is like,
Yeah.
Can you sell? Can you write code? Can you wash the dishes? No, forget it.
There are people who build stuff and there are people who sell stuff. That's it. There's only two.
You can always build like a hybrid, right? You can some parts use relational, some parts probably not SQL.
Yeah, it's very
take
early
advantage
days.
of both. Yeah.
It's very early days.
Yeah.
Right? I think if you look at it, relational databases have been around for 3 decades. And they're still evolving. Right? These things have been around for 5 years. So it's surprising how far they've come in just 5, 6, 10 years, right? And it's just very early days. It's going to evolve. It's going to get better. And every release and another thing I have pointed out is most of them are relatively immature. If you're used to working with SQL or Oracle, there is a level of stability and a finish that you expect. You won't find that in any of the NoSQL databases. Like when they crash hard, right? And the expectation is you know what you're doing and you'll go in and clean up and bring it back up.
Wow.
Right? And it's still early days. It'll get there, but it's very early days. And like I said, they don't have 3 decades of engineering in that, right? Like Oracle probably has 3,000-4,000 well-paid engineers working on their product for the last 20 years. Like these guys have 10 engineers working on them feverishly for about 5 years, right? So it's the difference in quality is heaven and earth. So we just gotta take that into consideration.
Is there a way to use an RDBMS for some components of the greater data stuff, and then use the NoSQL for the I guess the low-value bulk data. I hate to say it that way, because if you talk to people who are on Facebook, grandmas with pictures.
Unstructured data. Unstructured data, yeah.
Okay.
And a lot of people do that. And you see a lot of hybrid deployments.
Okay.
And again, it depends on your scenario. Like if you're trying to fit 15 terabytes of Facebook logs into SQL Server, good luck. Right? It's not going to fit. Right?
Okay.
But if you're trying to fit those 15 terabytes in Mongo or Cassandra, they'll deal with it fairly easily.
So you could have some information, like I was thinking, my husband works for EMC, and one of their vertical markets is healthcare and life sciences, and so that is, your genetic material. I mean, your terabytes and beyond of information that you're gathering about human beings, and so it would be possible to store. It would be possible to store the heavy, repetitious data in the MongoDB, for example, and then the more critical patient results and patient information in the RDBMS.
Definitely.
So you could kind of balance that way.
Yeah, all change will be gradual, right?
Yeah.
People are not going to throw out their RDBMS anytime soon.
No.
Because they've spent a couple of decades on that, right? And other problem with NoSQL databases is the lack of skill set. Right? For you, like let's say for example, you start on it today, right? To get to the same level you are with SQL databases, it's going to take you a year plus. And the database, the platform is also evolving, so it makes it hard. It's like you're moving on a running platform, right? So it takes time. And the two places where I see the most adoption are first one is the web properties we talked about. All the new startups, most of the new startups, I would say about 30-40% are based on Mongo today. That's because of the scale and the geo support and the frameworks like Node and Meteor.js. And the other part where I see a lot of adoption is data warehouses. People dealing with terabytes and petabytes of data who don't want to pay Oracle $1 million, right? They are starting to use some of these frameworks because they don't really have a choice, right? If you have ever tried building a data warehouse in SQL, you would know, it's just a nightmare. And you need a highly skilled, you need a big team, and it's definitely a very skilled person, and very expensive hardware, and it just
be Microsoft.
Yeah, like a star schema, and you do all that. And
are there any popular data warehouses on MongoDB?
not, it's very early. There aren't any.
Because I was thinking, I was just thinking how you would write a data warehouse.
Yeah.
I find it like
Basically, just store the raw data here.
Right now it's
So
right now it's
warehouse is
how can I
raw
design a
data.
cube on this? I was thinking how can I
you
design a
have to
cube?
use
so all those things will come. They're not
I
there
know.
yet, right?
I find it very
So I think Pentaho is working. Have you heard of Pentaho? They're like an analytics company. They have started working on Mongo, and it's going to happen. It's going to take time, but it's going to happen.
Yeah, I think the raw data, the ETL portion,
Yeah,
but for Cube you can definitely
Yeah.
SQL Server.
and there are a whole bunch of people who are doing on SQL Server and Oracle today, right? And those people will also sense the market opportunity, and they'll start doing on Cassandra and Mongo. And I think we talked about the cost-wise, it's very beneficial because it's open source. And in terms of where it's going, are they going to replace relational databases? Probably not. But it's a big market, right? It's a 60-70 billion market, right? I think they will make a big dent in that market. Right? I think at least from where I see right now, DynamoDB from Amazon side, and Mongo and Cassandra from just the NoSQL side, they will eat into a lot of that market. I don't have numbers on to what part of the market is OLTP databases versus data warehouses, but I think the data warehouse market isn't there. And, it will still take time because there's already a lot of expertise in the data warehouse market. There are already data scientists trained in SQL. They know nothing about these. So it's still going to take a decade to get there.
Job security.
Yeah.
Yeah.
But I think
Typically.
the technology is getting there.
Yeah.
And it's definitely going to get better. That's about it. Any questions?
What else service like your company does?
So basically, we help people run MongoDB on public and private clouds.
So
For example,
your cost, your services, for example.
so they bring their own servers. Like for example, I have a lot of companies on Amazon,
Okay.
and they want to run a big shard, right? Let's say they want to run 3 shards with a terabyte each, right? So, but they don't have Mongo expertise, right? They want to analyze 1 million tweets or 1 billion tweets a day,
Okay.
and they need 3 shards of a terabyte each, but they don't have the expertise to do that, right?
Okay.
So they basically come to us and they use our software to basically deploy the shards, to monitor it, to back it up, to restore it, to upgrade the version, to scale it, and if a server disappears, they'll use our software to rehydrate the server, and, patch the OS. Basically, all the operational aspects of maintaining Mongo server is what we do.
So you do basically the tooling,
The tooling, yes, and the
Okay.
support.
and the support, human support as well.
Yes, and human support.
Oh, that's that. In case we need your service, right,
Yeah.
in the future.
Yeah, even if you have tooling, you always need human support, right? Because it's always some percentage is gonna fall through.
Tengen already provided some of this, right? So how is that different?
Yeah, Tengen provides some part of it, but they are focused mostly on the database. Like they won't help you on Amazon, or they are not experts on Amazon or Rackspace or DigitalOcean. They'll tell you, hey, set up this shard and then let's talk after that, right? So what we do is we provide comprehensive, we have expertise in the cloud as well in the database. So we know how to set up a shard for high availability in Amazon, We know what sort of SKU to choose on Amazon. We know what sort of disk to choose on Amazon. And we have all that condensed knowledge, and we automate all that. And you can use our software, you'll get like a best practice deployment on that cloud. And we'll also help you scale. Okay? So Tengen will provide you support for Mongo in case you run into a bug with Mongo. Right? So I can't support that. I will help you with your operations, but in case you hit a bug with Mongo, then you have to go to Tengen. So that's where the difference is.
Mongo is on Linux.
So it works on Linux and Windows.
Okay.
They started off with Linux, so obviously it works better on Linux.
Okay.
Could you talk briefly, you had one of your first slides was about the data models.
Yeah.
And I was wondering if you could just say briefly what the difference is in between the four. I think a document, column, graph, and then key values.
So it's...
And then you
Yeah.
said that you went to MongoDB because you were following the money, and I was wondering, well, why would all the money be flowing to MongoDB? So if you could talk about that just a little bit.
What I'm thinking was in 2000 people were moving to MySQL.
Yeah.
For the same reason people are going to
Yeah.
MongoDB, right? Do you agree with me on that? In early, when MySQL came, people all moved to MySQL because it's free and
It's free,
things
yeah.
like that.
I think they're moving to Mongo because it has the features they want.
I mean,
I think it's already, because they're already on MySQL, I don't think cost is an issue. They're moving to Mongo mainly because the frameworks are driving them there. Like I said, if you're working with Node or Meteor, your database by default is Mongo. If you're doing geoqueries, your database by default is Mongo. If you want to store files and structure data together, then your database becomes. If you're working with a lot of JSON data, again you go to Mongo. So they are very well crafted, that feature set, to attract the right developers.
And then these four different
These
types
are just
here.
high level classifications. I'm sure a lot of them will not fit the perfect. You can go and there are n different ways of slicing and dicing. But in a very simple high level, DynamoDB is just a key value. It's a giant hash table. You have a key and there's a value, and it scales to terabytes of data and distributes across multiple nodes without you having to worry which server it's on. You don't have to patch servers. You don't have to patch software. It's all taken care of for you, right? But it's just key value pairs. All you can do is store something and look it up. And now they've added some secondary indexes as well. So your query functionality is very limited. But typically you use that schema when you have something that just key value pairs. There's no hierarchy, there's no schema, it's all very simple. You have a billion customers and they each have a piece of data. Put it there, you take it out. There's no querying, there's nothing much. So it's very simple, which is what gives them the scalability, right? But if you were trying to do that with a relational database, right? Imagine all the trouble you'd have to go through, right? So they solve that particular use
So
case.
prototyping is perfect.
Yeah. No, actually a lot of, for example, right, what was that, Moz, right? The search company based in Seattle. They are all completely based on Amazon. They just use key value pairs.
Yeah.
And they do key value on S3. So they don't have a database, by the way. It's all S3, key value pairs. You put in the key, you get a value, that's it. There's no query. They have petabytes of data on this. And the graph databases are, again, they're interesting. Basically, you can model your data as a graph. And they have special query semantics. For example, LinkedIn or Facebook, all just connections and people, right? Very easy to model as a graph. That is the native sort of data structure for that. And all the queries are optimized for it. And you can try and use it. Cassandra and HBase are mostly column-oriented sort of databases. You can go look for white column databases with a lot of information. It's typically when you want to read one column of all the rows or something, that is optimized for that.
Are
That's just
any
one
of
of
this
the things.
in memory as well?
For example, Mongo is in memory
Really?
as long as it wants to. As long as if the data fits in memory, it's completely in memory. If it doesn't fit in, it goes into that.
That's with anything, right?
Sure.
As long as you have the RAM, it will try to fit in.
Yeah. So again, it depends on your definition of in memory, right? In memory is what happens when it doesn't fit in RAM, right? Does it just fail? For example, Redis, I'm sure, is in memory. Redis is again a key value pair. You cannot even call it a database; it's a cache, right? So there are a bunch of, I don't think it's exclusively in memory. It tries to be in memory as much as possible. And the way it works, I think it achieves that a little bit. But I don't think it's in memory in the way you're talking about.
Because that is, HANA is completely in memory.
Yeah. So what happens when it runs out of memory?
No, the estimation is like that. They'll estimate it and they'll buffer it.
Yeah. So you could run any of these databases like that as well. Just create a RAM disk and put it on it and work just fine. But that's not what it was optimized for, right? And the last one is document databases. This is Couch and Mongo, and they're essentially optimized for storing like JSON. Like when they say document, they actually just mean a JSON snippet.
So Mongo does not support graph. Okay. So that probably have to use a hybrid if I want to.
Yeah. And graph databases are kind of their own thing, right?
Okay.
They have their own storage, they have their own sort of
Scale.
own schema, their own queries. And
Is the text searching any better in this? MongoDB?
well, they just recently released it. From what I've heard, right, if you use Elasticsearch is still better than Mongo. It's just the first release, right? So from what I've heard from at least from my customers, they all use Elasticsearch still. And, you're talking about full text index.
Yeah.
About Elasticsearch still.
So if you've got a group of developers,
Yeah.
and like you said, flexibility has its dark side. What's the best way to, for me as a no longer writing code person,
Yeah.
what's the best way for me to sort of enforce or introduce some disciplines?
Yeah.
For example, like to make sure that the way we're building our data set now, it is scalable.
Yeah.
We can scale it out. No, we're not making stupid mistakes in terms of how we're structuring.
So one simple way to do it is just design your schema. Right? You just have a schema. You can sit down and have the discussion like, what are your primary keys and what are your indexes? If you ever scale out, what is going to be your partition key? Right? If your queries don't use the partition key, then you're in trouble.
Right. But if you're not, like you said, if you're not a database guy, if you're a programmer, you don't necessarily think in database terms.
Yeah. So I would say schema design is a good way to force them to think in terms of, right? Get them to write the schema down, identify the primary keys, common queries, the common indexes that have to be added, and what are the validations that are needed, right? And unfortunately, in most of these cases, the validations need to be in code. But you can call them out beforehand. For example, you can say, like we said, the person field, last name cannot be empty, address cannot be empty. So you can enforce that in code, right? So you can follow the same process that you are following in a relational database. It's just that there are some extra things you need to do yourself.
We can enforce most of in the REST services we write to.
Yeah, and then also, right, a lot of this is hidden behind ARM models, like object relational models. Like, what are you using? Are you in Ruby?
Yeah.
So I think, what are you guys using? Mongoid?
Yeah.
Yeah. So I'm sure they have their own features there. So you can tag all the classes to say, it'll map properly. So just by using that ORM, you already are solving a lot of the problems, right? Because you're just dealing with simple classes, right? So now we just need to make sure the validation is there, and you need to make sure that people have gone through the thought process of the schema.
I'm using LinkU.
Yeah, same.
It has all the
link.
You mentioned that it is important to make sure that the indices fit in RAM. If I have a TTL index defined on my Mongo collection, will it have to be in RAM as well? Does it count against the index in memory?
So if the index has to be accessed, then it will have to be in RAM.
But Mongo claims that for TTL indices they implement the background process. I'm quoting their documentation.
So they have made a lot of changes to that. So TTL indexes, the requirements are much less stringent than normal, indexes. But the problem with indexes, if you have an index miss, it's 2 page faults. First page fault to bring in the right portion of the index into memory. And then once it's there, it knows what page is there, and then it has to go. If that page is not in memory, it has to get that page. Right?
So let's say the TTL typically done for implemented for deleting data, right?
Yeah.
It's not that you have to read the document.
Yeah.
You just have to get there and delete
Yeah.
it.
TTLs are very special. The fact that they're called indexes is kind of like
That's why
it's just a background process. I'm not aware of all the details, but I can dig into it. But with normal indexes, you need to worry about it if it doesn't fit in memory.
we're about to ship our first interaction of the hybrid system where we're offloading the payloads, large payloads to Mongo with the predefined life cycle of those, right?
Yeah.
And we're trying to see, and we're talking about quite a large number of documents, hundreds of millions.
Yeah.
And we just need to make sure that that we can keep, even though we're shipping with 3 shards, we want to make sure that our primary keys are sitting in memory most of the time, and that TTL will not impede the performance of the primary, operation.
So there are a couple of ways you can monitor that. One is you can keep your eye on the page faults. See how many page faults the system is hitting. And second is there is
As
something
Mongo
called,
stats.
there's something called Mongo monitoring service. So you can monitor the page faults, or even Mongo stat will give you that. And another thing is there's something called a working set analyzer. So after your system has been running for a little bit, you can find you can turn on the working set analyzer, and it will tell you how fast your working set is changing. If your working set is changing constantly, then you're in a bad place. It means pages are being constantly swapped in and out. What you want is the working set to be relatively stable. So that's something you can use as well.
Oh, slowly migrating, right?
Yeah, or moving very slowly, essentially.
Okay.
So that's something you can do. Right? And I can look up the TTL stuff, and I can.
Yeah, it would be just.
Yeah, if you give me a card or something,
Sure.
I'll share my card with you guys as well. And I have a card over here. Please feel free to. And then if you give me your card, I'll.
Sure. I don't have card, but I can give
Yeah.
you mine.
I found an easy way of converting SQL tables into collections. Very easy.
Yeah, it's very analogous, right? So it's very easy to.
In C# we could do with few lines of code.
Yeah.
We can easily do that.
And that's the other advantage Mongo has. It's very similar to relational databases. So people who know relational, very easy to grok. Cassandra is a little bit more different, right? Because the way they do things is different. So you have to sit and read Cassandra. But Mongo, you can just kind of learn it on the go. But both of them have their uses. I think both of them will do very well.
Okay. I think any other questions?
It seems like the document data model might be the most akin to the traditional relational database. Is that right? Or?
You're probably right on that, yeah.
Okay.
What is the reason? You mentioned one of the cons is I guess for lack of better terms, sort of mission critical transactions.
Yeah.
It's not, it wouldn't be your first choice. Why is that? What's inherent in? Is it just same plain old maturity?
So it's maturity and scalability as well. So a lot of these scale restrictions you have in relational databases, right? They're because of all these strict requirements for ACID. So what these databases have done is they have relaxed some of these properties for scalability. Like, let's say, for example, in Mongo, you have to do a transaction that goes across shards, right? That's basically like a throughput killer right there. Right? So they force you to do everything in one shard. And the way they do it is by removing transactions across documents. So a lot of it is religious. So like I said, there is a Mongo clone called Toku, and they provide ACID transactions, complete ACID transactions. Like you could, like SQL Server, everything is getting committed.
All fell over.
All fell over, everything, yeah. So it's a religious sort of discussion.
Right.
But there's no technical reason why they couldn't do it.
Yeah.
And I feel they will come around to it because the need is there, right? The ACID transactions are there for a reason, right?
I mean, it's funny to sit back and watch, eons ago there was DB2, right?
Yeah, history is
and
just
then
repeating itself.
Oracle became into existence because DB2 was just way too expensive. And Oracle was cheap, relatively speaking, and it was fast, and so people went that way. And then it was SQL Server, right? And SQL Server was way cheaper, and who wanted to go? My first startup, we burned through more than half of our development budget just with Oracle licenses and hardware.
Wow.
Just to really get started developing. because the guys in Sand Hill Road said, if you build it on SQL Server, we won't fund you. Because in 99, SQL Server, there was questions whether SQL Server would scale or not. Right? So it had to be Oracle or not, or DB2.
Those times have changed now, right? Yeah.
Right.
So,
Right. So now you get, now the next generation is it's cheap and fast, and there's almost no startup cost there that you pay in things like mission
people cost.
transactions and people costs, and the understanding and the engineering maturity and availability of resources. And
And I think eventually, they'll get there. And the fact that there are these clones that are doing it tells me there's a reason. Right? So eventually they'll get there.
And then Oracle will buy most of them up.
I think I'm surprised, they haven't been bought yet. Right? I think Oracle will buy Mongo or something, or EMC might buy Mongo. EMC is a big investor in Mongo, so they might. You never know. Right?
Okay. So it's already 8:45, and you don't mind sticking around if people want to talk to you separately. So, let's thank Dharshan for the really helpful, informative talk, and that's it.
Thanks, man.
Thank you.